Hey guys, we've talked about DMVPN Phase 1. It's time to move to Phase 2. We saw what DMVPN Phase 1 did to our routing protocols and what Cisco's recommended approaches are with regard to mitigating those outcomes. Now it's time for us to start looking at the idea of Phase 2. And again, a lot of people get wrapped around the axles about this like it's something exceedingly complicated. You will be shocked at how easy it is to configure DMVPN Phase 2. Let's make it happen on the console. Now, really and truly, what it all boils down to is we need to change the behavior of our spokes. Altering the behavior of the spokes means we want the spokes to be able to communicate with other spokes without having to traverse the hub. So in other words, Phase 2 gives us the ability to create dynamic peerings or dynamic mGRE tunnels between our spokes. Now, there's something that I want to emphasize here. I teach control plane. I'm all about control plane, control plane, control plane, because it's the control plane and the exchange of information with regard to what transits the control plane that directly impacts the forwarding plane. So without the control plane, we're not going to be able to solidify or stabilize our forwarding plane. So it's important for us to understand one thing, and that is that irregardless of the fact that we have a hub and we're running point-to-point GRE tunnels in a dynamic nature between our spokes, it's not going to change the control plane traffic. Remember, we still have an NHS, a next hop server, that's running on the hub. So what I want to do is I want to make certain that we embrace all of this, and it requires me to change my drawing. So what I'm going to do is I'm going to make that happen real quick here. So what we'll do is I'm going to grab my eraser, and I'm going to take out all of the information pertinent to Phase 1, and we're going to start identifying everything we need to discuss for Phase 2. I don't want that pin, I want this pin. Yeah, there we go. So, Phase 2 DMVPN. It's very simple. What we did to this point was we created an mGRE tunnel on R2, tunnel 0. Well, all we need to do is go to all of the other tunnel zeros, and we need to put them also in mGRE mode. That's the extent of it. So mGRE here, mGRE here. I mean, there's zero complexity to it. I mean, it's an efficiency. It's designed to make our lives easier. We don't want to burden the hub with every ounce of transit traffic that we have that we're going to be working with. So what we're going to do is go ahead and let's make this operation happen, and then what we're going to do is we're going to explore at exactly what happens to our data in regular unicast flows, and then we'll experiment with the idea of the routing protocols running on top of it. Let's dive right in. All right, so looking at this, what we have is on my spokes, I need to change the behavior of my device. So I need to say interface tunnel 0. And all I'm going to do is I'm going to say tunnel mode GRE multipoint, and I'm going to hit enter. But the problem is this: I can't set the mode. I can't set the mode because I have a tunnel destination. Well, we need to remove that. Do show run interface tunnel 0, and all I'm going to do is I'm going to remove my tunnel destination. Why? Why do I want to remove my tunnel destination? Well, my tunnel destination configuration is going to be taken off because I'm going to become an mGRE tunnel. So in other words, I'm going to have the ability to be able to dynamically make links to my spokes. That's the whole purpose for that portion of the configuration. The next element to this is the fact that, remember, I get reachability information from my next hop server, the hub. The hub is going to tell me the identity of all of the other devices that are registered with it. So what ends up happening is in one fell swoop, I now have the capability of learning the identity of my neighbors, the other spokes, from the next hop server, and by having an mGRE configuration, what I'm going to do is I'm going to get the capability of being able to create dynamic links to reach those spokes while not having to traverse the hub for every piece of traffic that I have. So what we're going to do is we're going to remove the configuration here. I'm going to simply say no and plug it in there and take it out. Now what I'm going to do is I'm going to say tunnel mode GRE multipoint. And let's see what happens now. Notice my link came down, interface down or detached. The moment that I bring it up for multipoint, the link comes back up and becomes operational. Let's do the same thing on 5 and 6. Face tunnel 0 do show run interface tunnel 0. I'm going to go ahead and take my destination out. And I'll do it over here too, just to bypass the process. Interface tunnel 0. since it's all terminated on the same hub. So now all we need to do is go to these devices and make them mGRE tunnels. So tunnel mode GRE multipoint, done. Tunnel mode mGRE GRE multipoint. All right, so did I not? Oh, I didn't do the no. Good catch, Hammond. I was just showing you what not to do, guys. So show DMVPN. Notice now I'm good to go. I've got my dynamics. Let's go down to one of our hubs. Well, we're on R4. Show DMVPN. Now I have my static config. Now what I want to do is I'm going to do a trace route. I'm going to say trace route to 10, 10, 10, and I want to ping or trace route from R4 to R6. So I'm going to ping or telling it to 6. I'm not telling it, but trace route. Now something just happened. Terry, I thought you said that if we configured mGRE tunnels, we would not traverse the hub. Well, we will not traverse the hub so long as we have a cached entry provided for that device's reachability, that spoke's reachability, from the NHS. If there's nothing in our table, then what we're going to have to do is we're going to spend one packet basically to build the control plane to allow our DMVPN environment to work. So let me repeat this trace route. Well, doesn't look like we're going through. Show, run, interface, tunnel, 0. Let's make sure we're good to go here. And they want to see show, run, interface, tunnel, 0. All right, we got multi-point GRE. We have no destination. This was all working. So let's go to 4. We have IP, NHRP network ID, 3542. Do, show, run, interface, tunnel, 0. We've got IP OSPF, point to multipoint. I need to take all those off anyway. No, exactly, Hamed. There's no requirement on the hub for a destination, because what happens is it show IP NHRP detail. What ends up happening is the hub or the spokes communicate to the hub and they give us all of our registration information. So what ends up happening is the system then externally extrapolates that, and then what it does is through NHRP notifies all the spokes of all the reachability information. So let's go down to R4. Well, no, we'll do R6. Let's see what we have here. End. Show IP, NHRP, detail. So what I want to do is I want to double check something here. I'm going to say ping 2222. Ping 3333. Oh no, 444. Let's do a trace route. But are we forming dynamic relationships? Let's take a look at this. Show IP DHCP or show IP DMVPN. Show DMVPN. See, all we have is our static configurations. Something's not working. So let's take a look at our config. So on R2, show IP interface or show run tunnel 0. All right. So what are we seeing here? We see the tunnel that we have configured. We see the configurational requirements for it to become operational. But the point here is are we missing configuration anywhere in our infrastructure? Because really and truly all we're doing is we're building a phase 2 DMVPN. Now the idea was that we wanted to be able to let these devices talk to each other directly, but The question now becomes is are we going to, or do we have everything that we need in order to be able to let this function? So when we go through and we do the configuration, and again, bear in mind we're doing dynamic mapping. Let's cut over to R4 and see what we have. Show, run, interface, tunnel, 0. Let's see what we got. Well, we're running a routing protocol right now. So what I want to do is I want to take that off. Let's go to R2, and we're not just going to run a straight environment. So config T, interface tunnel 0, and I'm going to remove my routing protocol. No router OSPF 1. We go to 4, no router OSPF 1. Do show run interface tunnel 0. Interface tunnel 0, no. Shrikant has it. I just want to get all the complication out of the area. So interface tunnel 0. No. Because when we do this again, we're going to look at it from the point of view of EIGRP. And then lastly, 6. Do show or show run. And no router OSPF 1. And so let's verify this real quick. Show IP OSPF interface brief, nothing. Show IP OSPF interface brief, nothing. Show IP OSPF brief, interface brief, nothing. Show IP OSPF brief. And what do we have? We've got absolutely nothing in the configuration now. So let's take a look and see what's going on. See, before what I was doing is I was pinging the loopback address. What we need to do right now is look at the reachability information associated with everything that we have in our base config. So let's take a look at this, just from a 30,000 foot view. So on R4, show IP or show DMVPN. Do show interface tunnel 0. Now it's being suggested that we need to get rid of the map. Well, the problem is we can't get rid of the map. The map is going to be problematic for us with regard to, if we take it off, we're not going to be able to reach the next hop server, of which the hub is still part of our control plane mechanism that we're using to build this DMVPN tunnel. Now what I was doing is I was resolving reachability using our loopback addresses. Let's look at what it would be involved in just pinging the tunnel interfaces, okay? So let's do that. So from R4, if I ping 10, 10, 10, and let's say 5, do or show DMVPN. Now look what happened. D. D means dynamic. So now we have a dynamic tunnel. Now what I want to do is I want to jump to one of my other devices. So we'll come up here and we'll go to, let's see, we tested to what, 5? So let's test to 6. All right, now let's do a trace route now. So we'll trace route to 4.4.4.4. Let's see what happens. Well, we got something going on here. So we don't have any reachability to 4.4.4.4. So let's take a look at this. So can I ping 4.4.4? So 6 can't reach 4. So again, we need to verify our configs. So let's go over here and take a look at what's going on. Show run interface tunnel 0. Now this is going to be a common scenario that you may find yourself in, especially if you have to convert. So here, notice we've got the dynamic. I went ahead and configured the static mappings. Now we've got our network ID here. And from the hub, show DMVPN, I have all 4 devices. Notice all 4 devices and they're dynamic. So let's cut over to R4 and see what we got. Show DMVPN. Well, here I've got my connection that's static to 2 and my dynamic to 5. So let's go over here from the point of view of 5. Show DMVPN. Well, let's see. Here I have a static configuration and I have a dynamic configuration to 4, but my traffic didn't go through. Well, let's see here. What did I ping? So from 5 to 2, because that's static. So let's go 5 to 4. So 10, 10, 4. Went directly to 4. It went directly to 4 because I have this dynamic tunnel that we just created. I know we don't have any routing protocol running. Sometimes I lose sight of the fact I was pinging 4.4.4. So now when we come up here, show DMVPN, I don't have an entry for 4. Let's do a trace route now. So well, the IP that I should have pinged was 10.10.10.4. And notice it went through the hub. But I thought you said, Terry, that it would go through the dynamic spoke. Well, let's take a look and see. Does that spoke exist? It exists now, and notice it's dynamic. So let's repeat that trace route. Notice now it bypassed the hub. What you just experienced was control plane formation with regard to how these spokes get created. Irregardless of the fact that we're running multi-point GRE on the spokes, if we do not have an entry in our table in order to be able to allow us to resolve the identity or the IP address of the next hop device that is the spoke, we have to query the NHS. So let's look at that one more time. So what I'm going to do is I'm going to say clear IP NHRP, or clear NHRP, NHRP, and what I want to do is I'm going to say period. Now do show, or show DMVPN. Okay, notice I only have my static here. So let's do a trace route again to 4. Notice it went through the hub. The moment it went through the hub, I learned the identity of my destination, so now any other subsequent pings or trace routes are going to traverse directly to the spoke. Very, very critical that we understand this. Very, very critical that we realize that we've just changed the behavior of our infrastructure, which means we need to relook at what we're going to be doing and how we're going to handle this idea of running routing protocols on top of our DMVPN configurations. All right, with that being said, we'll explore EIGRP in the next video. I'll see you guys there. Bye-bye.